linear polynomial, that word is referring to an expression that can be represented like this. And m here is just a constant, so that could be a number, be the number 5 or the number -3/2, or it could be the number 1 times x, which is a variable. A variable is not a constant number, it's just a symbol that could represent any of a set of numbers. And then plus b, b is again a constant. And there's a whole lot of vocabulary words that I want you to be familiar with on the page right now. So first of all, this is a linear polynomial. M, sometimes we call it the slope. Like when we're talking about graphing this as a line, this will be the slope of the line. But we also call this the leading coefficient, because when you write it in this expanded form, it's the first number you see, so it's a leading coefficient. The b, if you're going to draw the line that represents this linear polynomial, then b is going to be what we call the y-intercept. It'll be the point where the line goes through the y-axis. But we also call it the constant term, because there's two terms here, a first term and a second term. And this term is constant, whereas this term is variable. So if I say the word constant term, we're talking about the term that doesn't get a variable. And when we choose to represent our linear polynomial in this form, mx plus b, this is what's called the expanded form of a polynomial. So easy question for you. What is the leading coefficient of 6x minus 5? 6. And what is the constant term? -5. Okay. Questions? Okay. If I say linear function, a linear function is a rule where you have some input value x, and the function tells you how to return an output value y. And a linear function is specifically a function where the output is equal to m times the input plus b. So it looks like a linear polynomial on the right side. And this is how you define an output value. So if I tell you to evaluate the following function, I'm telling you find the value y that you get as an output if I give you a specific input. So this time my input is the number 12, and this is what it looks like to evaluate the function. Evaluate the function means you plug in the input value 12, where you see the x in your function. So we've got y equals -3x plus 5. Now we've got y equals -3 times 12 plus 5. And then that means y is equal to -31. Right? It would be -36 plus 5, so -31. That means when you give me the input value 12, I give you the output value -31, and that's how a linear function works. And that's what you do if I ever ask you to evaluate a linear function. Does that make sense? Evaluate means you plug in the x value and you calculate the y value. If I ask you to use the following function to complete a table of values, this is what I mean. My table of values is going to have x on the left and y on the right. And then it tells me what x values to use. In this list right here, it says use the x values, -3, -2, -1, 0, 1, 2, 3. And then to create a table of values, what I have to do is evaluate this function at each of these x values. I'm going to plug in each of those values for x and then calculate the corresponding value for y. And so it's going to be 2 times x minus 3. And so 2 times 0 minus 3 is just minus 3. 2 times 1 minus 3 is minus 1. 2 times 2 minus 3 is 1. And 2 times 3 minus 3 is 3. 2 times -1 minus 3 would be -5. 2 times -2 minus 3 would be -7. And 2 times -3 minus 3 would be -9. Does everybody understand how I used the function to generate that table of values? Exactly. I just plugged in the values of x to calculate y every time. All right, number 4. Let's identify whether or not each of these expressions is a linear polynomial. Is that a linear polynomial? Yes, because it looks like mx plus b, right? Is that? No. This is not a linear polynomial because we're not allowed to have x squared, right? It just has to be constant times x plus a constant. What about this one? This one is a yes because I could write this exact same expression like that, where m is 9 and b is -18. It's not written in expanded form, but you could write it in expanded form. And that's the important part. Is that a linear polynomial? Yep. Because I could choose to write this in expanded form, mx plus b, where m is -3/5. So that works. And what about that one? Yes. Because x to the power 1 is just x, and x to the power 0 is just 1. So 42 times 1 is 42. That's the same thing as 42 times x to the power 0. Because anything to the power 0 is just the number 1. And so that really is constant. And that makes this a linear polynomial. Questions? Feel good? Okay. If I ask you, rewrite the following linear polynomial in expanded form, how would you write this in expanded form? Yep. You distribute the 7 inside the parentheses, so you get 7 times 2/3 would be 14/3. And 7 times -x is -7x. And I swapped the order of the two terms because the standard way to write the expanded form is to have -7x plus 14/3. What is my constant term? 14/3. What's my leading coefficient? -7. Very good. So that's how you do exercise 5 on your homework. That's how you do rewrite the following in expanded form. So, the factored form of a linear polynomial is m times parentheses x minus r. And once again, x is our variable. M is still called our leading coefficient. And this time r is a number called the root. In the polynomial 3 times parentheses x plus 4, what is the leading coefficient? 3. And what's the root?
X plus 4. Or just 4. Oh, negative 4 or something?
Negative 4. Yes, exactly. In this, the root is negative 4. Because if I were going to write this, as 3 times x minus, notice the minus sign, x minus the root. The root is negative 4 because we're expecting to see x minus the root. So x minus negative 4 is the same thing as x plus 4. It would be wrong to say that the root is positive 4, because if the root were positive 4, we would see x minus 4 inside the parentheses, if the root is positive 4. That's tricky. That's hard to remember, so make sure you try to remember that fact. Is that in the factored form, we see x minus the root inside the parentheses. Okay, rewrite the following linear polynomial in factored form. So right now I gave you 2x plus 5 in expanded form. If I wanted to rewrite this in the form m times x minus r, how would I rewrite this?
2 times x plus minus 5 over 2.
Like that? So if I think about distributing the 2, I would get 2 times x, that's good, minus 2 times 5 over 2, that would be minus 5. Oops, so this should really be x plus 5 over 2, right? Because if I distribute the 2, I need to get back to my expanded form that I started with. These have to be equal to each other. What is the leading coefficient of this polynomial? 2. And what is its root? Negative 5 over 2. Yeah. So of course this is 2 times x minus negative 5 over 2, which simplifies to being x plus 5 over 2. There's a new vocabulary word coming up. We say a linear polynomial is monic if the leading coefficient is the number positive 1. Not negative 1, but specifically positive 1. So it makes this monic. And if you happen to have a monic linear polynomial, it would look like one of these things, right? It would be positive 1 times x plus the constant. But that means, your expanded form and factored form are really the same thing, right? So if your leading coefficient is 1, then your expanded form and your factored form are really the same thing, right? Imagine m is the number 1. You don't have to write it if it's just a positive 1. Multiplying by 1 doesn't do anything. And then you don't have any reason to keep these parentheses, right, if you're not multiplying by anything. So you just have x plus or minus a constant. And that's what I mean when I say the expanded form and factored form is really the same if you have a monic linear polynomial. So you might see that in an example. Which of these linear polynomials, there's 6 linear polynomials here, which of them are monic? Is this guy monic?
Yes.
Yep, because the leading coefficient is 1. What about that one? No, because the leading coefficient is 2. What about this one? Yes, because that is the same thing as x minus 5/3, which is monic. What about 5 plus x?
Yes.
Yes, because this is the same as x plus 5. What about 7 minus x?
Yes.
No, because this would be minus x plus 7. The leading coefficient has to be positive 1, not negative 1. Okay, what about this one? Yes. Because this would be positive x minus 20 when you expand it. All right. Questions? No? Solve the following linear equations. And so these are called, sometimes in an algebra class, they're called two-step equations because it takes exactly 2 steps to solve the equation. If I wanted to solve 8x minus 1 equals negative 4, what's the first step?
Just get the negative 1 on both sides, so add 1.
Add 1 to both sides. And when I add 1 to the left side, it cancels out the minus 1. And when I add 1 to the right side, this becomes
3, or negative 3.
negative 3. Now, what is the second step?
You divide.
I divide both sides by 8. The 8's cancel on that side, and on the right side, I get negative 3 over 8 as my answer. 2-step equations. What about this? What's my first step if I want to solve x divided by negative 3 plus 5 equals negative 1?
Remove the 5.
I'm going to
Subtract 5.
subtract 5 from both sides of my equation. I get x over negative 3 is equal to negative 6. What's my second step? Multiply by negative 3. So multiplying by negative 3, the negative 3's cancel on the left side, and on the right side I get 18. If I want to solve x plus 9 divided by 4 equals 7 over 6, what's the first step?
You gotta multiply the, not multiply, multiply. Split 5. Yeah, that's fine.
I'm trying to solve for x, and so maybe the first thing I'll do is I'll multiply both sides by 4.
Could you also multiply both sides by 6?
I mean, you could. It would keep the equation balanced as long as you do the same thing to both sides. So that works. The 4's cancel, and I get x plus 9. And on the right side, 7 times 4 is 28. And then my next step is I want to subtract 9 from both sides. That solves for x. Of course, you want to simplify your answer. You know, those would be like the 2 steps in my 2-step equation, but we always want to simplify our answer after we get our answer. And 28 and 6 are both divisible by 2. That could be 14 thirds. I also want to represent 9 as a fraction, something over 3. Yeah, 9 is the same thing as 27 over 3. That's how we find a common denominator, right? I've got a 3 in the denominator. Multiply times 3 over 3. And I get 14 thirds minus 27 thirds. And that's going to be, I want to say minus 13 thirds. Yeah. So that's your final solution after you simplify it. You're probably right, though. If I started off by multiplying both sides by 4 and multiplying both sides by 6. You wouldn't do both?
You wouldn't?
I don't know. You can try it in your own time. You guys have lots of free time, right? You can try whatever method you want. As long as you get the right answer at the end of the day. That's what matters. All right. In this equation, we have 2 times x plus 5 in parentheses equal to 18. What's the first step? I could distribute the 2 inside the parentheses, or I could just divide by 2. If I divide both sides by 2, the 2's cancel. On the right side, 18 divided by 2 is 9, and I don't need these parentheses anymore because I'm not multiplying anymore. And then my next step would be to subtract 5 from both sides. Let me find x equals 4. Do we have any questions about what we've done in the last few equations here? That's all. All right. These linear equations could get slightly more complicated to where you've got like a 3-step or a 4-step equation, you know. We'll see how this one goes. This time I've got 2 times x minus 3 minus 17 equals 13 minus 3 times x plus 2 in parentheses like that. You know, if I'm looking at this, I think the first thing I would do is try to simplify the left side and simplify the right side by distributing. Yeah, I heard the right word. We want to distribute the 2 inside the parentheses and distribute the 3 inside the parentheses and just kind of put both sides in expanded form. Like both sides are a linear polynomial at heart here. That's what makes it a linear equation, is if both sides can be written as a linear polynomial. And I think that's what you get after we distribute. And then I might also add 6 to both sides. What happens if I add 6 to the left side? Yeah, and then if I add 6 to the right side, get rid of that. Then I might think to myself, let me add 17 to both sides. And also add 3x to both sides. 2x plus 3x is 5x. And those cancel. 13 plus 17 is 30. And then those cancel. Lastly, I want to divide both sides by I want to divide both sides by 5 in order to cancel this 5. And then what would be 30 divided by 5? 6. So that one is a little bit more complicated. Again, I said this in passing, but what makes these equations called linear equations is because both sides could be represented as a linear polynomial. Any questions about how we did that one? Thoughts? Okay. Here we go. What do I want to do when I see x plus 2 divided by 4 minus x minus 1 over 3 equal 2. What's going through your head?
Maybe multiply by, okay. Multiply by 4. It can be either. Right?
Yeah. One thing to kind of keep in mind if you've got an equation, don't know where to go first. A good first step is always to get rid of denominators. So if you see like fractions going on here, I want to get rid of this 4 and just be done with the 4. And I can get rid of the 4 if I choose to multiply all terms in my equation times 4. Then I am keeping it balanced because I do the same thing to the left side of the equation as I do to the right side of the equation. But that's going to get rid of my 4. So 4's cancel in that first term. I get x plus 2. And then I'm going to get like 4x minus 4 over 3 here. Because I have to distribute. Right? The 4 can't just multiply the x. It has to multiply everything up top here, 4x, and 4 times minus 1. And then 8. I still have the 3 denominator, and I can get rid of the 3 if I multiply everything on both sides of my equation times 3. So that means 3 times x plus 2 times 3. And when I multiply this term by 3, the 3 is going to cancel the 3 in the denominator. And so I just get, yeah. And then 8 times 3 is 24. I was really careful here. I was careful to use parentheses because I still have to distribute the minus sign into the parentheses. If you had a plus sign, you wouldn't really need parentheses, but since I have a minus sign, I've got to be super careful about keeping track of my minus signs. And so this is going to be minus 4x plus 4, because 2 negatives make a positive. That could be an easy mistake to make if you're not very careful. Collecting like terms means I have 3x minus 4x. 3 minus 4 is just minus 1x. 6 plus 4 is 10. I'll subtract 10 from both sides and get negative 1x equals 14. And then you can divide both sides by negative 1 or multiply both sides by negative 1. And that just tells me that x must be negative 14. And but maybe the tricky part about this equation and solving this equation was trying to figure out how to start, right? Like, what's your first step? A lot of times the best first step is to try to get rid of the denominators. You just have to multiply the left side of the equation and the right side of the equation by every denominator you see in order to cancel those out. Feel good about that? Let me know if you have questions. If anything there is confusing or if I'm making mistakes as we go on. So back to vocabulary for a moment. We have seen already linear polynomials, and we have talked about how to discover the root of a polynomial. This linear polynomial says 5x plus 15. If I wanted to write that in factored form, what I've typed out here is expanded form, but if I wanted to rewrite this in factored form, I would write 5 times parentheses x plus 3. That would be factored form. And you can tell from the factored form that the root is negative 3 because we expect to find x minus the root. And so if you see x plus some number, then the root must be negative. And what I want to point out next is that if you write a linear function, then it's y equals a linear polynomial. And the new vocabulary word is the word 0. If I ask you about the 0 of a function, that is the x value that makes y equal to 0. So I say the 0 of this function is negative 3, because if I choose to plug in negative 3 for x, that would be 5 times negative 3, which is negative 15, plus 15, and negative 15 plus 15 is 0. That gives me a y value of 0. That's why I'm calling this the 0 of the function. Yes.
Same with the x value?
Yes. Does that make sense? You plug in this number for x in order to make y the number 0. Okay. And you probably understand how this works. I would say the solution of this linear equation is negative 3, because if I plug in negative 3 for x, then the left side of the equation is equal to the right side of the equation. That's what solves an equation, is when the left side is equal to the right side. And a lot of times we can get lazy and interchange the word root and 0 and solution. Right? You might just casually say that the root of this linear function is negative 3. But it's because they have this in common. The root of the polynomial is the 0 of the linear function based on that polynomial. And it's the solution to a linear equation based on that polynomial. So root, 0, solution. They all kind of mean the same things, but we talk about solutions of equations, we talk about zeros of functions, and we talk about roots of polynomials. So I might ask, find the 0 of the following function, and what would be the 0 of this function? Three. The 0 of this function is 3. We say the 0 of this function is 3 because if I plug in x equals 3, I would get 3 times 3 minus 9, which gives me a y value of 0. So on your homework, that's what exercise 11 is asking you to do. You find the x value that makes the y value equal to 0. Okay, exercise 12 says, use the function to complete a table of values. This is the same thing we've already done, except this time the function is in factored form. So, it's not that different. It's the same idea. You just plug in these values for x in your function and then calculate the y value. So if I start with, let's say x equals 0, 0 minus 3 is negative 3. Negative 3 times 2 is negative 6. What if I plug in x equals 1? 1 minus 3 is negative 2, and negative 2 times 2 is negative 4. You could do that too. That would give you the same answer in the end, right? This is in factored form. But she just asked, could I go ahead and just write this in expanded form and then do my table of values? And the answer is yeah, you could totally do that, and you should get exactly the same answer if you choose to do that as well. Because these should be identical. If you've done your problem right, they should be identical functions. That's a great question. All right, in exercise 13, we are moving on to graphing. And if you are given a table of values for graphing, you just have to find the coordinates and place dots, right? So where I just placed a dot is where the x value is -1 and the y value is 7. When x is 0, y is supposed to be 4. When x is 1, y is supposed to be 1. You don't have to write these on your graph. I'm just writing this to help you. But you don't have to do this. You can just show me the dots. X is 2 and y is -2. X is 3 and y is -5. When x is 4, y is -8. And -11 is not really on here, so we can stop. But if I were to connect the dots, connecting the dots gives me a line. And this is the case if you use a linear function to generate a table of values and you plot those dots and you connect them, you should always get a line, and that's why we call them linear functions. It's a function that makes a line on a graph. Is that straightforward? Anytime you have a linear function, like we recognize this is a linear function, it's going to make a line. If I want to graph this, I said this at the very beginning of lecture, but this is the constant term, and it's also called the y-intercept. Yeah, it's also known as the y-intercept. And that means on my y-axis, this line is going to pass through the y-axis at the point where y is +1 on the y-axis. And this -2 is my leading coefficient also known as my slope. And what we mean by the slope of a line is rise over run. If you have a slope of -2, like we do here, a slope of -2 means that if I move from left to right, I'm moving in the right direction. If I move right by 1 unit, I'm going to go down 2 units. -2 means you go right 1 unit and you go down by 2 units. Okay? So every time I'm moving to the right, I move down 2. If my slope were a positive number, I would move up. Negative number, I move down. And then that's how I can graph it. If I only know the y-intercept and the slope from looking at my function, I can still make dots by moving to the right 1 unit, moving up or down according to my slope, and connect the dots. And if I were to extend this, because I know for a fact that this is a line, I could also move to the left 1 unit and move up 2 units just to extend my line farther. I'm just going like that too. Does that make sense?
Yes, sir.
And I want to point this out too, because you might want to check your work on your homework, right? I'll try to post solutions, but in case I don't, if I don't ever get around to it, how do you check your work on graphing problems? Go to desmos.com, T-E-S-M-O-S. I have this typed on the back of your homework page. And then you just type in what we're doing, which was, hold on, negative 2x plus 1. And then say, does that line exactly match the line that I drew? And yeah, it looks like it's actually, like that's the thing. Passes through the y-axis at the right y-intercept. It's got the right slope. We're doing good. So that's how you can check your work if you don't have an answer key. What we've been calling the expanded form of a linear polynomial, this is called the slope-intercept form of a line, because when you look at that linear function, you see the slope and the y-intercept. So you might hear me call this the slope-intercept form, and that's why this is called the slope-intercept form. You can look at it and you can tell what those two values are. Now, if I want to graph a linear function with slope 1/4 containing the point -3, 1, I would start by graphing the point -3, 1. This is, by the way, called an ordered pair. I've told you that this was a point. And if I tell you a point and I give you parentheses, a number, comma, another number, close parentheses, that means I'm going to give you the x-coordinate first and then the y-coordinate second. So the x-coordinate is -3, the y-coordinate is +1, and that's how I place that dot. If my slope is 1/4, of course this is rise over run. And this time I'm going to move to the right how many units? I'm going to move to the right 4 units, and I did that wrong. Since the slope is positive, I'm going to move up 1 unit. Right? The rise is only 1 unit for every 4 units I move to the right. And then I connect my dots. I see that I have made a line, and I can choose to even continue the line on the left if I want to. But that's how you do it. You put the point first, and then you use the slope as rise over run. So you move to the right 4 and move up 1. Now, if you hear the term point slope form, of a line, this is what we're talking about. It's the formula y minus y with a tiny little subscript 1 on the bottom right corner of that symbol equals m times x minus x with a tiny little subscript 1. And the definition here is that this point, this coordinate pair, x1, y1, can be any point that belongs to the line. So there's infinitely many choices you have to choose a point along the line. You just pick any one of those and it's going to work. And of course, m is the slope, like it was before. And this is called the point slope form because you can look at this formula and you can tell what one point is on the line and what the slope is. So in exercise 16, it says, write the linear function that contains this point and has this slope. The way you do that is you say, this point is telling me x1 is minus 3, y1 is positive 1. Slope of 1/4 tells me that m is the fraction 1/4. And then you remember this. This might just be something you have to memorize for test number 2. And the thing to memorize is you write y minus y1 equals m times x minus x1. Okay. If you're looking at exercise 16, right? We just wrote a linear function that contains the point and that has a slope. But taking a test, I might give you answer choices, A, B, C, and A, B, C, D, and E. I will probably give you your correct answer in like expanded form. And so you might want to continue simplifying this into expanded form, also known as slope-intercept form, right? And if we want to put this in slope-intercept form, you want to distribute the 1/4. Minus negative 3 is plus 3. And we distribute the 1/4, so it would be plus 3/4. And then I need to add 1 to both sides. And adding 1 to both sides makes that 3/4 into a 7/4. And this is more than likely what the correct answer choice is going to look like. It's the same line, but I wrote it in slope-intercept form. Does that make sense?
7.
The 7? Good question. So I need to get rid of the 1 on the left side for the minus 1. So I add 1 to both sides.
Oh, okay.
And so I'm adding 1 to the right side. And 1 is the same thing as 4 divided by 4. So I chose to add 4/4 so that 3 plus 4 is 7. And you keep the same denominator and write 7/4. But that's a good question. I'm sure other people are wondering too. So we ended up with something else. All right, let's see what we got. Determine the slope of the line shown. Can you guys tell what this slope is of this line? Perfect. So slope, remember, is rise over run. And what you're trying to look at is, pick any 2 points along this line, like maybe that point and that point. So the numerator, the rise part, is going down 1, and the denominator, the run part, is going across 3. So this is negative 1 over 3. Rise over run. Does that make sense to everybody?
Yes, sir.
Okay. If I want to complete a table of values and I'm given a line, just choose, they're telling you what x values to use. If I don't tell you what x values to use, then of course, just pick some. But in this case, I told you these are the x values we're going to use. What are the corresponding y values? That looks like -8. And again, what I did here is I started at x equals -2. Go directly vertical. Only travel vertically. To the line that's plotted, and then after you find the line, only travel horizontally to get your x value, which is -8. If x is 3, +3, you travel only vertically to get to your line, and then you travel only horizontally again to get to your y value. And so this x equals 3 corresponds to y equals 2. And you can fill in the rest of the table the same way. Or you might notice a pattern. These linear functions, you might notice the pattern in the table. If the x value goes up by 1, then the y value goes up by 2. So the slope is 2, and so that's how you can fill in the table according to the pattern, if you notice that. Okay, what if I want to write the function shown in this blue graph? Any idea of how I could do this? I just need to find the slope and the y-intercept, and then I've written the function, right? So what's my slope? 2?
2.
Yeah, so let's clarify this. If I need my slope, pick any 2 points on your line, like maybe these 2 points. And the rise part is +2, but the run part between these 2 points is just 1. And so we're talking about 2 over 1 when I say rise over run. So the slope is +2, and what's my y-intercept?
Is that 4 or 5?
It's -4. So my y-intercept, where my line passes through the vertical y-axis, that happens when y is -4. And that's how we get our written out linear function. All right, write the slope of the line, or what is the slope of the line, that contains these 2 points. So, slope is rise over run. What we mean when we say rise is we've got some point over here that I'm going to call point number 2. And point number 2 has an x-coordinate and a y-coordinate. And we've got some point over here, which I might call point number 1, and it has an x-coordinate and a y-coordinate. And I gave them little subscripts to distinguish which point the x and y coordinates belong to. And the rise part this part is really y2 minus y1. That tells me how much change in the vertical direction, how much change in the y direction I get. The run part, the change in the horizontal direction, is x2 minus x1. That tells me what's the difference between these points only in the horizontal direction. And so I can write this formula. I can say the slope is equal to the second y coordinate minus the first y coordinate divided by the second x coordinate minus the first x coordinate. And so this would be 5 minus what? 3. And then 1 minus what? Negative 2. 5 minus 3 is positive 2. 1 minus negative 2 is 3. So the slope here is 2/3. If you have a line that contains those 2 points, then that line has slope 2/3. This might be something you have to memorize, okay? If you had trouble following that line of reasoning, you might just have to memorize the fact that the slope can be calculated from this formula. Because you have exercise 20 on your homework where you need to use this logic for exercise 20. And anything that shows up on your homework might show up on your next test. So you might see this on the test and you can know that.
How does the 1 minus negative 2 into 6?
So 2 negatives make a positive.
Okay.
That's like 1 plus 2.
Okay.
Yeah.
If you switch the points, does it still work? It doesn't have to be.
It does still work.
Okay.
You'd be right. His question was, if you switched the points in that formula, would it still work? And I'll show you why that would work. That's my formula, right? What happens if I multiply times 1? That doesn't change anything, okay? Well, negative 1 divided by negative 1 is just 1. So again, this is not changing the value of the slope if I choose to multiply by negative 1 over negative 1. But then I'm going to have to distribute in order to multiply across. So I'll end up with minus y2 plus y1, right? Because it's minus a negative. I'm multiplying the negative 1 times negative y1, so I get positive y1 in the end. And then the same thing happens in the denominator. And addition is commutative, so it doesn't matter the order in which you add things. Since addition is commutative, I can say this is the same thing as y1 plus negative y2, also known as y1 minus y2, and then the same thing in the denominator. So this is exactly the same as if you were to swap the order of those subscripts. You'll get the same answer because you're just really taking the negative of the top and the bottom, and it doesn't matter in the end. You'll get the same answer. So we could have done, for example, maybe this will clear it up. If you had instead said 3 minus 5 divided by negative 2 minus 1, I just swapped the order. 3 minus 5 is negative 2. Negative 2 minus 1 is negative 3. But 2 negatives make a positive, so negative 2 divided by negative 3 is positive 2/3. They're the same. Swapping the order doesn't matter. Great question. So memorize it any way you like, as long as it works. And the next one, we want to find the linear function that contains the 2 points above. Okay, so we just found the slope. We know what the slope is for this function. And if you didn't already find the slope, you would need to find the slope before you could write the linear function. We're going to start off exercise 21 in your homework. We're going to start off by writing point slope form. And again, this was just something that you would need to memorize. and I'll switch colors because for us, y1 is the number 3. Because that's my first point, and that's the y coordinate. My slope, we just found the slope, that was 2/3. x1 is -2, because that's the x coordinate of my first point. And so by following the point slope form formula, plugging in the right values for m, y1, and x1, I got an equation. And this equation is going to describe a line in the plane that passes through those 2 points. If you want to double check your work, you can jump onto Desmos, and there's a few things I need to type out. Like, for example, -2, 3, and 1, 5. Those are the 2 points we're trying to get, and then the equation I just found, which is y minus 3 equals 2/3 times x minus -2. Right now I'm just checking my work to say, did I do everything correctly? For our purposes, I'll make these points a little bit more visible. And yeah, Desmos agrees that this equation describes the green line, and that green line passes through those 2 points that I got from my question. Okay? And that was my goal, right? The linear function that contains the 2 points. Of course, if this is a test, and you might see this question on a test where you've got multiple choice A, B, C, D, you might see this in slope-intercept form, right? I might give you a simplified version of the answer. And of course, you would need to write y equals 2/3 x. And then you would get +2 times 2/3 is 4/3. 4/3 plus 3 is 4/3 plus 9/3, which would be 13/3. And so this would be the way your answer shows up on an exam, where you have to distribute, you have to solve for y.
So where did you put the 3 on?
Yeah. Sorry, I apologize for skipping steps. I'm trying to let you guys out of class on time, but I'll show you as quickly as I can. Minus -2 is the same thing as +2. And then when I distribute the 2/3, this is 4/3, because it's 2 times 2/3, gives you 4/3. And then I add 3 to both sides. On the left side, adding 3 cancels out the -3. And on the right side, when I add 3, I'm going to add 9/3. 9 divided by 3 is 3, so I'm adding 3. But the reason I'm choosing to do 9/3 is because I'm trying to add this to 4/3. And then I can just say 4 plus 9 is 13/3. Okay, a few more questions to go. If you want to write a linear function that generates these points in this table, here's what you do. Select one of these points, it doesn't matter which one, and you can call this point number 1, so that x1 is 2 and y1 is -2. Select another point in the table, and it doesn't matter which point you're choosing. Call it point number 2, so that x2 is 5 and y2 is -11. Okay? Now, we write the point slope form formula. And you know what x1 and y1 are that go into this formula. When you want to discover, hey, what is my slope? That's when you have to pull out the formula you memorized for the slope, which is x2 minus x1 divided by y2 minus y1. Now you know what those numbers are to plug into the slope formula. Simplify to get your slope. Then you know what your slope is to plug into this point slope formula. You know what the y1 and x1 are, right? And then again, you might have to simplify to get your answer. Oh, thank you. Did I mess that up earlier too, or just there? All right, thank you for catching that. You're absolutely right. I'm glad you guys are paying attention. Y's go on top because the slope is rise over run. It's the change in the vertical direction divided by the change in the horizontal direction. Y is the vertical direction, X is the horizontal direction. That's why it works. What equations represent horizontal lines? If I tell you y equals 3, and that is the equation, that's telling you I don't care what x is. Y is always 3. No matter what the value of x is, y is always 3. That makes a flat line in the plane in order to keep your y value always 3. So, in other words, the kind of equations that represent horizontal lines are the equations that look like y equals some constant number. Okay? The equations that represent vertical lines, like this vertical line here, is like x equals 5. This tells you no matter what y is, I don't care. I don't care what y is, so it doesn't get to show up in my equation. X is always 5. And of course, the set of points in my plane where the x value is 5 makes a vertical line. So if you don't see y at all, and you only see the equation x equals some constant, that tells you it's definitely going to be a vertical line in the plane. Makes sense? Yep.
Does that mean there's no slope?
That means there's no slope. Kind of has like infinite slope, right? This is a line where there's all rise and no run. Or you might say the slope is undefined. That might be a better way to say it, because you're dividing by 0. This would have no slope, or slope equals 0 when it's horizontal and completely flat. And I don't think we're going to be able to finish this set of notes today. Here's what we're going to do, okay? If you've got to leave at 12:20, then I understand that's the end of class time. I want to finish talking about this so I don't have to save it for Tuesday. I'm going to go ahead and keep talking into my microphone. And you guys are welcome to stay if you want to. If you have to leave, this video recording will be on YouTube, posted to our Canvas page. You can catch the last 5 minutes of class by watching that video. Okay? So you are free to go if you need to. But I'm going to keep talking. And you can catch this on the video recording in a minute. Now, if you want to start selling disposable cameras at a stand-up each, let's say you sell the cameras for $15 every camera sold. Yeah, that's it. But you also have to buy these cameras first in order to sell them. So your supplier is selling these to you for $9 each. Okay. In addition, if you're also going to have a stand on the beach where you operate, you've got to pay rent. So let's say rent is $825. We want to write a linear function that represents my net profit as a function of the number of cameras sold. And this is going to be $15 of profit per camera sold minus $9 of profit per camera sold, because I've got to replace my inventory. And also minus $825 because every month I've got to pay my rent. So for any 1 month, this is my profit equation. And I can simplify this as just 6x minus 825, because 15 minus 9 is 6. And that is the answer to the first bullet point here. That's my linear function. If you tell me x how many cameras you sold, I'll tell you why this is your net profit for the month. Okay, second bullet point. What's the zero of this function? The zero is the point we get whenever I set y equal to 0. And we ask, what is the x value that makes y equal to 0? And so I would add 825 to both sides of this equation. And then finally, to solve for x, I would divide everything by 6. On your next test, by the way, you can use this TI-30X2S calculator. And so you can actually type in 825 divided by 6 if you want to. And this is the number 137.5. This is the zero of your function. $137.5. And there's one more bullet point. When I ask you, what's the significance of this, right? What does it mean that the zero of this function is $137? Or sorry, not $137. The zero. What's the mean that the zero is 137.5? What does that mean?
Means like you broke the profit.
Exactly. If you sell less than 138 cameras, then you lost money for the month, right? Then your rent was more money than you earned. But if you sell 138 cameras or more, then you've actually made a profit. So this is what we call the break-even point. Where you actually start to make a profit. You go from losing money to earning money if you can sell 138 cameras over the course of a month. All right, questions about how we do this problem? So there might be a question like that on your test. There's a question like that, exercise 23 on your homework. Number 24 on your homework looks a little bit something like this. It says, a train is rolling directly away from Midland at a constant speed of 70 miles per hour. When the time is 5 a.m., the train is 200 miles away from Midland, And our first task is to write a linear function that represents the distance away from Midland as a function of the hour of the day in expanded form, or point slope form, if you want. So what this is going to look like is saying y increases by 70 when x increases by 1. Does that make sense? Y is my distance, and x is my hours. Every time 1 hour passes, my distance increases by 70 because I'm traveling at a speed of 70 miles per hour.
So would that be like a point on the graph?
That's going to be my slope, actually. Because slope is the change in your y-coordinate divided by the change in your x-coordinate. And I'm saying if this x2 is just 1 more than x1, that means my y is going to be 70 more than the previous y value. Hopefully that line of reasoning makes sense. You know, if you're struggling understanding that, then just try to work the problem on your homework the same way we're working it here in class, and maybe you'll get it through practice. So slope is 70. Now there is a point I can put on my graph. That is when the time is 5, the distance is 200. So we'll call that x1 and y1. And then we'll write the point slope form of a line. And plugging in everything into my point slope form, that was a 5. This is what I would get for point slope form. Of course, my question asked me to do this in the expanded form or the slope intercept form. And so I'm going to first distribute the 70 and then add the 200. And so this is going to be 70x minus 150. Okay. So far, so good. That's my first bullet point. The second bullet point is going to ask you to find the 0 of this function. The 0 of this function is the x value that makes my y value equal to 0. So just by writing y equals 0, I get that equation. And that means 150 is equal to 70x. And then I can take x equals 150 divided by 70. Which is going to be 2.14-ish. That's what we call the 0, because it's the x value that makes the y value equal to 0.
So on the homework, like let's say it's like 2.138, would you want us to round up?
Yeah.
But then if it's like 2.13, do you want us to round down? Or like 2.23?
Yeah. So on your homework, it doesn't really matter how much you round to. On a test, it will either be multiple choice, where you can just select the correct answer, and I'm not going to give you like annoying it. I'm not going to make one choice 2.13 and another choice 2.14. I'm not going to do that to you, I promise. So rounding won't really matter if it's multiple choice. If it's a free response question, then I will tell you exactly how many decimals places I want you to round to. Good question. And the last bullet point says, what does this mean, right? In the scope of my problem where the train is going away from Midland, what does it mean when I say the 0 happens at x equals 2.14? That means the train was in Midland or leaving Midland around 2, and you don't have to give a specific number, but like 2:08 a.m. Does that make sense? A little bit? Because if y is equal to 0, that means the distance from Midland is 0 miles. That means we're in Midland. And this is the hour of the day, right? The hour of the day is 2.14. So 0.14 times 60 minutes gave me 8 minutes. And that's why I said 2:08 a.m. It's okay if you say around 2 a.m. That's fine too. I'm not going to be super picky about questions like this where you have to give an explanation. But if you see on your homework, what is the significance? That's what I want you to say. Just in the scope of your word problem, what does it mean anyways for your application? Again, I'm sorry that we're going so far over time. If you have to go, you can go. I'm just doing this for my recording. I'm actually talking into a microphone, and I hope it's capturing this as a video so we can watch it later. General form. I know we've already learned way too many forms, but the general form of a linear function or a line looks like ax plus by equals c. So if I ask you to rewrite the linear function in general form, that means we can rewrite this as 4/3 x minus 7 times 4/3 is going to be negative 28/3. And the only thing I have to do is subtract the 4/3 x to move it to the left side of the equation, plus y equals negative 28/3. Yeah, that'll do it. Now I'm in general form, but I'll tell you this too. If this is a test question, I might also represent your answer choice a little bit differently because you can make this look nicer. There's a way to make this look a little bit nicer. And that is, if I have all rational numbers, I can multiply both sides of the equation by the denominators, and I'll end up with only integers. And so the integer version of this is to multiply everything by 3. And I think that looks nicer. I want you to know that these are the same equation. Exactly the same equation. They mean the same thing. They plot exactly the same line on a graph. But this is considered the simplified general form of a line. The last question says, graph the following function, and you'll notice that it's given to you in general form, 2x minus 5y equals negative 10. You could do this multiple ways, okay? You could either rewrite this in slope-intercept form by rearranging the equation, and just using your algebra skills to solve for y. Alternatively, you could say, if x equals 0, then the equation becomes negative 5y equals negative 10. And therefore, y must be 2. So if x is 0, y is 2. And then another thing I like to do is say if y is equal to 0, then what happens to my equation? If y is equal to 0, then I just write 2x equals negative 10. And that means x equals negative 5. So here where y is equal to 0, x is negative 5, and I can plot another point. I like this method because I don't have to rearrange the equation. And it's pretty easy to find those values if you set x equals 0 or y equals 0, and then find the other one. And if you have 2 points, 2 points fully defines what your line is, right? It even helps if you have a ruler or the edge of the paper and you can line it up and you can draw a line through both of those points and you have graphed the function.